Alright, let's take a look at the most missed problems. We're going to start with number 76. It says the graph of the function f on a closed interval -6 to 11 consists of two semicircles, two line segments, as shown above. Which of the following is not true? So the first one says f prime, so we're looking at a graph of f, so it's really saying the slope of the tangent line at -3.5 is 0. Alright, so -3.5 would be somewhere between -1 and -6. So there is some potential for that being true. Alright, I'm going to go ahead and keep looking and see if we can find for sure. Alright, it did tell us that was a semicircle, so if we go in between here, that middle point will be at -3.5. Alright, so I'm confident that one's true. Alright, if I go to f prime of -1, alright, exists. Alright, so there's some potential there if we just think of it the graph, but when we think of this in terms of being semicircles, we know that semicircles go vertical right at that point. So we likely have a vertical tangent line here. So right now, that's my initial thought of false. I'm going to keep checking the others just to make sure. So f prime of 4 does not exist. So the derivative at 4, right, does not exist. That's true. There's a corner there. Alright. F has a point of inflection at -1. Alright, that's true. It goes from concave down to concave up. And F has a relative maximum at 7. Alright, at 7 we definitely have a high point. It's actually an absolute, but absolutes are also considered relative. Alright, so we know for sure the others are true. We also had a pretty good hunch that this one was going to be the false one. Right, because the tangent line is vertical, which means that the derivative is undefined. Alright, so B is our correct answer. Alright, if I go to the next one we had questions on, it was 80. It says the graph of f prime, the derivative of a function f, on a closed interval -3 to 7 is shown above. Alright, so I'm going to make a big note to myself that this graph is f prime. If f double prime of 0 equals 0, which of the following statements is true? Alright, so f double prime of 0 equals 0. Alright, which is clearly true here because the slope of this tangent line is 0, and that's a picture of the first derivative, so that slope would represent the second derivative. Alright, so it says A, and this is we're looking for true this time, the graph of f has a point of inflection at x equals 0. Alright, so the second derivative is 0. And the second derivative goes from negative, because this is decreasing, to positive, because this is increasing. Alright, so this one is true, that we have one at 0. Alright, but we need to check and make sure that it's not other places as well. So it looks like we have a potential for another change from increasing to decreasing at x equals 3. Alright, so this one overall is a false. Alright, if I go to B, it says the graph of f has a relative minimum, alright, at x equals 0. Alright, so relative minimum happens when the derivative, which is this graph, goes from negative to positive. So if I look at this graph, the derivative is actually never negative here, so it's always positive, so there's no way that we can have a relative minimum. Alright, so this one is a no. Alright, if I go to C, C says f is not differentiable at 3. If I go to 3, there's a defined point there, so for that derivative to be defined at 3, the function had to be differentiable at 3. If it wasn't, that would have had to be an open circle. Alright, so that's false as well. Alright, D says the graph of f is continuous at x equals 3. Alright, that has to be true, because the only way we can be differentiable and have the derivative defined at that point is if it's continuous. Alright, so right now that's our leader for being true. E, it says the graph of f is concave up on the interval -3 to 0. Alright, from -3 to 0, the slopes of this, which correspond to the second derivative, are negative. And when the second derivative is negative, it's concave down. So that one's false as well. Alright, so our correct answer here is D. All right, and it hinges on the idea of differentiability. All right, the last one that came up as a most missed question was number 81. This says the function f given by f of x equals x sine x squared over 2. How many points of inflection does the graph f have on the interval 0 to 5? All right, so we're going to need our calculator on this one. So we'll get that open. We're going to get the function typed in. So x sine, so I'm going to go to y equals. And we've got x sine quantity x squared over 2. Alright, and we're going to close that off. And just double check and make sure that we've got that entered right. We do. Alright, that's the first derivative. And it said how many inflection points. And from 0 to 5. So I'm going to start with window. I'm going to go from 0 to 5. Alright, it's x times sine x. So really, sine is between 0 and 1. Or negative 1 and 1, sorry. So the max in min would have to be between negative 5 and 5, because that's the biggest number that we'd be multiplying that by. Alright, so I'm going to go ahead and hit graph. Alright, and we get this graph. Now, it's going to be a little bit difficult from the graph alone to have an idea as far as how many inflection points. I could take a guess here at how many inflection points we have. It appears to be, let's see, we've got 1 in that first spot. Let me copy this over so we've got it in the document there. Alright, so we've got, it appears as though we'd have 1 right about here. It appears as though we'd have another one right about there. Appears as though we'd have another one right about there. Appears as though we'd have another one right here. So from this graph, it looks like 1, 2, 3, 4. Alright, which would be choice E. Alright, so we can check and make sure by going back to our calculator. Go to y equals. And in the first line, I'm going to go the first derivative. Alright, so I'm just going to say math. N derive, which is 8. We want to take it with respect to x. We want the function y1. And we want that for all x values. Alright, then we're going to go down to the next one. We're going to do the same thing again. But this time we're going to reference alpha or y2. So we've got math, 8, x, alpha trace. This time we're choosing 2. Alright, and x for the variable. Now, I'm going to turn off the first two so that we're only looking at the derivative this time. Or technically the second derivative. I'm going to hit graph. Alright, so there's our first as it's graphing. There's our second. There's our third. And there's a fourth. So we have 4. And we've confirmed that in 2 ways. So at that point, we should feel really comfortable with the fact that that's 4. Again, honestly, with this graph, as long as we had a decent view window, getting the inflection points in this way wouldn't have been an issue. Now, in the AP exam, since it's free response, you would need to, it would be a question where you'd have to show the second derivative equal to 0 in a sign test. And that would be how you'd verify that it was inflection points. Now, one thing that I didn't do based on my graph, I feel pretty confident was right, is I did not check mode. Anytime you do trig, especially you physics students, anytime you see trig in calculus, make sure you hit mode and check and make sure you're in radians, which we are. Alright, so that was the most missed problems. I hope that was helpful. Thanks.